compliance and privacy team. He also oversees a team of security industry experts and leaders in the Google cybersecurity action team who partners with customers on their secure digital transformation. Before joining Google, he was a partner at Goldman Sachs, where he held multiple roles. Initially was their first CISO, where he held the position for 17 years. He also serves on the Information Security and Privacy Advisory Board of the National Institute of Standards and Technology. Please help me to welcome Mr. Phil Venables. Phil, you're on mute, Phil.
Okay, apologies for that. Can you hear me okay now?
Yep, we're good.
Yep. Yeah, sorry, automatically muted me when I started. I didn't know that. Sorry. So anyway, thank you. In this session, we're going to explore strategies for implementing effective cybersecurity, and in particular the need for IT modernization and as being an essential part of that. And just a little bit of further background. I've worked in many organizations and many different industries as a chief security officer and many other related risk roles. And in my current and prior role, I've worked with many organizations, large and small, public and private, to help them improve their cybersecurity. And one of the main patterns of failure that I've seen is where an organization invests a lot in cybersecurity, and in particular cybersecurity products and services, but does not upgrade or modernize the rest of their technology. And again, I think a lot of you will appreciate this is like building on a foundation of sand. Alternatively, one of the main patterns of success that I've seen is where organizations balance the need to spend on security improvements by upgrading their IT to more modern technologies, for which security is built in and not bolted on after the fact. Now, this doesn't mean you don't need cybersecurity products and services anymore. Rather, it means more of your security comes in your underlying infrastructure, and the more specific cybersecurity products and services strongly augment and validate that. So today in this session, we're going to explore some aspects of this and touch on some of what it means to modernize technology, including, we'll spend a lot of time talking about zero trust as well. So we can go to the next slide, please. So first, like just talking a little bit about a backdrop on kind of regulatory priorities and requirements. It's been really pleasing to see in recent years that the government, not just the US government, but other governments and other organizations that kind of stipulate standards and approaches have been actually starting to converge on this modernization theme. Last year's cybersecurity executive order was a great example of that. But also there's been much additional work that's driving towards embedding security through many other IT and software management practices, such as the ongoing work to improve software supply chain and open source security after major events like SolarWinds and Log4j demonstrated a need for ongoing improvements. And again, that's all about upgrading technology to be able to implement those better controls. And like many large technology companies, we at Google have and are committing even further resources in both time and money to not just help our customers, but actually help the community and the nation as a whole in trying to drive forward many of these kind of new technologies that enable this more modern approach. We'll go to the next slide, please. So just kind of, thinking about why IT modernization is important. And as I mentioned at the beginning, a key part of any cybersecurity effort is to ensure defenses are built into the overall IT architecture. And so we ultimately want this to be about secure products rather than just security products. And older or so-called legacy systems are not only hard to maintain, patch and keep up to date to mitigate discovered security vulnerabilities, but they've also not been architected with these practices in mind. And when I think about some of these modern security practices, it's like zero trust principles are vital not just for security, but as I think this audience in particular will appreciate, it's important not just for security, but it also balances productivity and agility with security. And I have to say, I'm going to deliberately not not try and make this a sales pitch for Google Cloud, but generally speaking, when I think about this as a prior consumer of cloud services, as well as in the position I'm at now, is really a lot of what people are finding is that cloud is a great example of an environment where security has been built in. And so a really, increasingly viable path for many organizations is to modernize into the cloud rather than modernizing in situ over legacy technologies. And I think that's going to be more so. And as cloud providers, I know we take that responsibility very seriously. Go to the next slide, please. So just switching our attention to zero trust. I'll just wait for the next slide to come up. Thanks. So let's talk in more depth about zero trust. As I think I've seen on the agenda today, it's been one of the more talked about topics, and in general, kind of zero trust is one of these most talked about concepts in security these days. But I actually also think it's one that is perhaps the least understood. Partly because it's a term that's been hijacked as a marketing term by so many vendors. I think if we're honest, and at Google, we've never been that comfortable with this term, even though we were one of the main originators of the concept nearly a decade ago. But we now use the term because the term is so pervasive. And so what we mean by zero trust is really not zero trust, but rather zero implicit trust. In other words, you need to explicitly verify trust levels, assume potential compromise of people and equipment as part of mediating access to resources. So let me give you an example. In many IT environments, if your device is on the corporate network, inside your perimeter, it's implicitly trusted to have broad connectivity. And if the person using that device is authenticated by, say, a password, they're assumed to be genuine. But we all know that getting on a corporate network, phishing a password, or even compromising a device with malware is possible. And sadly, for some organizations, it's a regular occurrence. And so while there's definite value in a network perimeter as part of a layered set of defenses, to rely on it for the majority of your defense from external intrusion is I think now outdated. And so in a zero trust environment, or as we described it, a zero implicit trust environment, you would mediate access based on explicitly and continuously verifying the integrity of the device, the authenticity of the person using strong phishing resistant authentication tokens like FIDO hardware tokens, or in our case, Google Titan tokens, with all communications being encrypted internally and externally. And essentially, the type of access and the resource criticality would determine how much trust needs to be explicitly verified. And this, of course, is all complemented by security monitoring from placed sensors, as well as telemetry from the zero trust components themselves. And such a zero trust architecture yields a level of defense in depth that makes it infeasible for opportunistic attackers to be successful, and very hard for even advanced and persistent adversaries to realize their goals, especially, as I just described, when security monitoring is in place to detect and respond to intrusion attempts. We go to the next slide, please. So in 2014, we as I mentioned, we codified a zero trust framework we call BeyondCorp, which implements these concepts. And this is deployed, including, as I mentioned, FIDO U2F hardware personal authentication tokens for our 130,000 plus workforce, and a similar number of additional number of contractors. And because of this environment, we've just not had a phishing event now for over 8 years. We continue to have this approach as one of our main means of defending ourselves against the significant attack levels we continuously face. And while the effort to deploy this was not small over the scale of our environment for the period of time we've had it in operation, the efficiency we've seen, it's not just a security improvement, but the efficiency we've seen from reduced support costs, agility in supporting different types of remote working, and other productivity benefits has more than outweighed that effort. And interestingly as well, employee resistance to the use of hardware tokens and constraints on their devices has been handled actually quite well by additional careful attention to usability, support, and provisioning improvements. We go to the next slide, please. And so, as I mentioned earlier, the term zero trust has become confusing because it's an architectural concept being used to describe products. And in reality, no one product completely delivers on all of this from what we've seen. And rather, it's an arrangement of some products and tools into this overall architecture that delivers on the benefit of a zero trust approach. So, for example, as you see in this diagram of our approach, we have everything from authentication tokens to endpoint devices, enterprise managed Chrome browser endpoints through to access gateways. And while we do have a product that we've made out of all this called BeyondCorp Enterprise that does encompass a lot of this, you still need to integrate that into your environment and couple it with your preference of layered endpoint defenses or monitoring tools. Next slide, please. And so we've talked so far about zero trust user access, and this seems to be the dominant conversation on zero trust in the industry. But one of the things, that's applied for on-premise and remote working, but really that's only part of the story. One of the even more useful opportunities for a zero trust architecture is what you can achieve in the management of and access within production business applications, databases, and other layers in the IT architecture. And so this is where we took the BeyondCorp principles and applied it over a number of years to production into what we call Beyond Prod. And so to use the same principles, this means that all production access and application communications are continuously authenticated and authorized to make no assumption of implicit trust. And what this means in practice is that all our literally trillions of inter-process app-to-app communications are mutually cryptographically authenticated, encrypted, and explicitly authorized according to a policy-driven allow list. And so this creates a default architecture of micro-segmentation, which not only delivers significant levels of security, but also helps application performance management and observability. And so thinking about zero trust, which is, echoes this point around viewing it as a primary security architecture goal, it's important to apply it to the production environment as well as the user access and remote environment. So we'll go to the next slide, please. So, when we think about the kind of the developer experience and environment around this, a key part of this architecture is not just to ensure the authenticity and authorization of inter-application communications, but it's also to ensure the authenticity of the software that underpins those applications. So again, we touched on this earlier, as you will have all seen during the much discussed software supply chain attacks. It's imperative to know the provenance of your software. And this is also a big part of what we call Beyond Prod, which is specifically that our software is managed under our control, is built in a secure and what we call a hermetic sealed build environment. And the output of that is digitally signed, and our runtime environment will only execute such authentic, authorized and signed software artifacts. In other words, zero implied trust is not just for user access and application runtimes, but it's also for software production. And that's, as we just mentioned, that's a really critical topic given everything that's happened over the past year. And so our internal approach for this is not just embedded into products that customers can use in the cloud, but we've also published much of this as open standards, like what we call SLSA. So this stands for Supply Chain Levels for Software Artifacts. And there's a great website, slsa.dev, which is where we've published this open source framework for how to think about software supply chain risk. And again, one of the things that we do with this in partnership with all of the software bill of materials work is to make sure that there's sufficient tooling and approaches to really assess your end-to-end integrity of the software production process, not just what's inside the actual software that you receive, which is why I think it's so important that we think of the right software risk management as being SBOM plus SALSA, as we call it. And again, to use an analogy, SALSA just published a blog recently which had a very good analogy. Is if you think about software security like food safety, well, SBOM gives you the ingredients inside the food, whereas SALSA describes the whole end-to-end safety framework for how the food is produced and well regulated according to hygiene and safety standards. So in reality, both are useful, but you need both together to achieve the right goal. The other thing that we've done with all of our zero trust approach to making sure software is developed securely is to, again, make a lot of these technologies available as open source projects and open source products that we run but make available broadly, like Kubernetes binary authorization, Envoy proxies, and Istio service meshes, which let you run a zero trust beyond prod style environment. And so we think that's kind of useful and made broadly available to the community, irrespective of whether that's part of the products that we offer. Go to the next slide, please. So I think it's important also to look at kind of what zero trust is not. So, as I hope you will have seen from what we've spoken about so far, again, zero trust is not a product, it's an architectural approach. And any vendor who tries to sell you on their solution as the complete package for zero trust either doesn't understand zero trust or is otherwise, trying it on like they might. And so it's important to make sure that as you think about integrating these concepts, which are immensely important, that you don't think of this as a point solution. It's also worth remembering that again, zero trust is not even a kind of a toggled feature in cloud. It's actually a way of running and using cloud. It's also not an end state that you only get the benefit from after some big complex journey. Rather, in our experience and what we see with other organizations' experience, is something that you get and can get incremental benefit from every step of the way, like improving the strength of user authentication or segmenting some of your most critical production applications, even if you don't segment everything. And it's also not a framework that is only confined to highly mature IT organizations. It can also be applied as part of a broader modernization strategy. And the great thing is, unlike some other types of frameworks or architectures, you don't have to wait for everything to be done to realize all of the benefit. You can get progressive benefits incrementally if it's implemented and staged in the right way. We'll go to the next slide, please. And so, just kind of switching gears a little bit as we start to wrap up, I think it's worth stepping back and talking about how all of this fits together. So, some of our most pressing issues in cybersecurity today include ransomware, managing cloud migration risk and transitioning off legacy systems, mitigating supply chain and software supply chain risk, reducing insider risks, all while balancing agility and productivity. Now, this is not an easy task, but as with a combination of adopting zero trust, applying this more modern IT approach, where the unit cost of control is reduced, you get more continuous assurance of the effectiveness of controls, and an ability as well to raise the productivity of your scarce cybersecurity workforce. I think the interesting thing is we as an industry talk a lot about the shortage of cybersecurity professionals at all levels, and then we immediately approach that by correctly, in many respects, trying to figure out how to train and create more cybersecurity professionals. I think the thing that we also need to do more of is worry about the productivity of the cybersecurity professionals we already have. And the great thing about many of these modernization approaches, especially around some of the zero trust concepts, is it substantially leverages the professionals we've got to make them more productive and more effective. And it takes some of that pressure off the hiring challenges and workforce development challenges we have on cyber. So ultimately, all of this approach, it becomes more feasible to achieve higher levels of security in more agile and economic ways that support the mission of the environment. Next slide, please. And so as we've seen, such a modern IT environment in the cloud, or to be fair, it could be on-premise in cloud-like ways, enables an environment where security is built in. It's not bolted on after the fact. It includes controls that are more pervasively deployed across the architecture, such as we've talked about strong authentication, pervasive encryption, finer-grained segmentation to reduce the risks of compromise, as well as speeding up detection and response. And you start to see various new effects that arise from this, such as economies of scale that drive that lower per unit cost of security. So you can really kind of think of this as it's raising the baseline of control by reducing the cost of control, so you can get higher controls in more places. Even while you're still investing more, you can get even more leverage out of that investment because the unit cost of control is decreasing in a more modern environment. You also, and this is especially for cloud, get to tap into what we've been calling the digital immune system, where organizations can sit back and take every one of a lot of frequent security updates that cloud providers provide. So, for example, every month we ship hundreds of updates that are new controls, new features that defeat whole classes of attacks, as well as remediation of vulnerabilities that we've postulated or discovered. And for many organizations, even organizations that, especially organizations that don't have large security teams, sitting back and taking every update that the cloud provider gives on security, you're effectively getting the effect of a rising tide lifting all boats. You're getting the benefit of all of the security knowledge of the wider ecosystem. And just without doing anything other than taking the updates, you're going to keep getting a raised level of security. And that, again, drives this kind of economic effect that we see is so useful in a more modern technology environment. So the next slide, please. But finally, as I wrap up, in the end, it's really speed that is our ultimate weapon for cyber defense. And this is the speed of modernizing the environment, the speed of adopting and taking new security updates from your vendors or your cloud providers, like I just described. It's also the speed of equipping your users or your kind of customers or your internal mission teams with new capabilities. And also it's about the raw speed of your so-called OODA loop, that is your kind of observe, orient, decide, act process in responding to new risks and threats. And in fact, I think as a set of cybersecurity professionals, ultimately our collective goal is to make and keep our defense OODA loop, our ability to respond, ever faster than the attacker's ability to respond and come up with new attacks in the face of our defenses. And I think, again, it's just figuring out what is slowing you down, modernizing your environment to improve not just security, but also that agility and the ability to adapt and keep speeding up the processes that really will drive, is the fuel for that ultimate cyber defense, which is everything is about speed and staying ahead and keeping ahead of the attackers. So with that, I will close. I think we have time for questions if there are any. So I'll let the moderator handle and let me know what questions there are.
Wonderful, thank you so much. So our first question queued up. What guidance do you have for organizations trying to secure their cloud environments?
Yeah, I think probably the main thing is to not. Well, it's two things. One is maybe the obvious thing, which is to use the standard secure builds that a cloud provider provides. So, for example, at Google Cloud, we have a set of standard secure default configurations and security blueprints that we've spent a lot of time based on our experience of running these services as what the default level of security is. And we ship that with configuration code so people can stand up those kind of secure landing zones for cloud. So it's taking that guidance, and often, especially important in a government environment, these are kind of FedRAMP assessed, and they come with kind of compliance certifications. So adopting the cloud provider standard blueprints for security is always a good start. The second thing, and this is a bit more subtle, is I think for IT teams, infrastructure teams, security teams that have spent their careers in an on-premise environment, it's certainly, you can recreate the on-premise security model in the cloud. You can do that in safe ways, but to do that doesn't realize the full opportunity of the cloud environment. So as I mentioned in some of the slides, cloud gives you this great approach where you can micro-segment things. You can adopt zero trust in easier ways than really was feasible in an on-premise environment. And so if you just move your on-premise philosophy to the cloud, you may be missing out on those opportunities. So I think there's definite, as organizations go to the cloud, thinking about how to re-equip and retrain teams to think more cloud natively lets you realize an exponential level of more security benefits. But if you don't, you can do it securely. But to really take advantage of it, you need to think cloud-like versus on-premise like.
Oh, right. Excellent. Thank you. Our next question. I'm sorry. Do you feel that the government is doing a good job of cyber intelligence sharing, and what could be done to increase collaboration in that area?
Yeah, I mean, I think there's been a reasonably good historical partnership over many years, either between companies directly with their contacts in government, or more formally through things like the ISACs and the ISAOs in partnership with various different government agencies. I'd say though, in the past year to 2 years, some of the new constructs in place, like we have this thing with the DHS cyber JCD cyber collaboration function that exists at least for the moment with the big tech companies that we're a part of. That's like a much closer operational level of sharing of in both directions to defend the nation is something that we're spending a lot of time on. And then similarly, there's a lot of other activities with sector-specific agencies and other parts of government in the context of particular critical infrastructure sectors. So, for example, we're part of multiple ISACs because of the types of businesses that we're in, and we support all of those with the work that we do. So I think it's generally good and getting better. But the reason I sound a bit guarded in any space like this, it can always be even better. And I think a lot of us are working hard, both in the public and private sectors, to just figure out how we keep that connection in that kind of name of constant shared defense. And it's back to that speed point. We want to make sure that we're getting all sharing things in as near real time as we can, as opposed to getting a briefing once a quarter, by which time the attackers may have evolved. So I think it's good, but it always needs to get better.
Thank you. I think we have time for one more, and it's another two-parter. How does social media affect cybersecurity, and could you provide any tips to minimize vulnerabilities?
So I mean, social media, I mean, you could kind of extrapolate this to kind of any communications, is an avenue for people to be duped by kind of disinformation, by phishing attacks, by other types of social engineering attacks. So I think there's we all have to be careful, and all of the providers of those services need to provide people with the ability to kind of help manage their risk in interacting in those online platforms. And and certainly on some of our channels, we spend a lot of time worrying about disinformation, authenticity, enabling people to select and tune spam filters and other types of filtering to protect themselves. And so I think that's just something that we're going to continue to have to manage. I would say though is when you think about the second part of that question about kind of reducing vulnerability, is when you think about risks of inbound communications either on social media or more conventional media like email, is you've also got to think about how you're providing the capabilities to defend your customers and internal users and other parts of your environment. So, for example, if you're having an issue with phishing and phishing emails, then maybe the answer to that is not to try and aim to have perfect filtering, and so zero phishing emails are hitting your employees, or it may not even be constant phishing assessments and training, which is never going to make everybody 100% immune, because the phishing emails are actually pretty clever. Maybe the answer is deploying authentication technologies that are not subject to having credentials that are phished, and that's the example I gave around shifting passwords, or even phishable one-time code authentication technologies, and shifting that to FIDO U2F style cryptographic hardware tokens that plug into your device that are just not subject to phishing. So I'm always a big fan of trying to shift the game from training and filtering into actually much more stringent but still usable controls that defeat a whole class of attack that otherwise you would just be trying to filter out.
Wonderful. Thank you so much for your time. I'm going to hand it back to Vu.
Um,